So, fine. Now, we know with what velocity the disturbance travels through the medium. Next, we will go to wave equation. Okay. Fine. So, source is creating a periodic disturbance. That periodic disturbance is traveling through the medium, okay, like compression, rarefaction and all. Now, I want to write the equation for this disturbance. The mathematical equation for this disturbance I want to write. So, that is called wave equation. What is the physical quantity that is varying periodically with time when sound is propagating to the medium? So, let me clear first this. I am writing in general. It is a source, here is the observer, S is the source observer. The angular frequency of the source is omega, the angular frequency is omega, and there is a medium, air. Let us say this direction is x axis, the disturbance is traveling along x axis. So, consider a particle of air at a distance x from the origin. Consider a particle. Okay. Under normal conditions, okay, pressure is 1 atm, density is constant. When source starts vibrating, that wave is traveling through the medium. Let me discuss first what physical quantity that is varying periodically. One is when sound is propagating through the medium, each particle of the medium undergoes simple harmonic motion. Each particle of the medium undergoes simple harmonic motion. That is the relation between sound and SHM. Okay. So, each particle of the medium undergoes to and fro motion. One. The second thing is, due to compression and rarefaction, the pressure also varies periodically with time. The pressure also varies periodically with time. That is called as pressure wave. If I write the equation for the particle, that is called displacement wave equation. If I write equation for pressure, that is pressure wave equation, and also the density also varies periodically. Okay. That is called density wave. So, when sound wave is propagating to the medium, displacement of the particles varying periodically, pressure is varying periodically, and density, that is three quantities. One is y, the other one is p, the other one is rho. Y is the displacement of the particle, p is pressure of the medium, and rho is right. Now, I am going to write the equation for these three physical quantities. Okay. So, displacement wave, pressure wave, and density wave. Let me write this one. So, since source is in simple harmonic motion, let us assume that tuning fork in SHM, even the particles of the medium also vibrate according to the source. Okay. So, these particles are dancing according to this source SHM. In SHM, we know that the displacement of the particle y is equal to fine, that is what we y is equal to a sin omega t plus or minus pi, where a is called maximum displacement from its mean position, that is called amplitude, y is the displacement from the mean position, omega is the angular frequency, which is nothing but 2 pi n, n is frequency. The frequency of oscillation of this particle is same as the frequency of the source, t is time, and pi is, in SHM we are calling pi as phase difference. Phase difference. Here this is a very important term. What is the phase difference? How do you calculate this? When you use plus, when you use minus. Let us say y is equal to a sin omega t. Let us take pi, omega t plus. So I'll explain afterwards when you take plus, when you take minus. So what is this pi? Here pi is the phase difference between the two particles of the medium, because when sound is propagating to the medium, every particle of the medium undergoes simple harmonic motion with same amplitude, same frequency, but different phases. This pi is the phase difference. I am going to calculate this phase difference for a particle which is a distance x from the origin. Let us say take a wave. Then how do you define wavelength of the wave? Wavelength. Let me explain what is wavelength. When source oscillates, we have a series of compressions and rarefactions are formed. Okay. You have a series of compressions and rarefactions formed. The distance between two successive compressions, or rarefactions is equal to one wavelength. Or we can say when source completes one oscillation, the disturbance travels some distance, that distance is called wavelength. When source completes one oscillation, it creates a disturbance, the disturbance travels some distance, that distance is called wavelength, lambda. We know that the phase difference between two successive compressions, that means when source complete one oscillation, okay, the phase difference is 2 pi radians. One oscillation is equal to 2 pi radians, 0, 90, 180, 270, 360, 2 pi radians. Okay. So that means 2 pi radians phase difference, 2 pi radians phase difference is equal to 1 lambda path difference. If I take any 2 points of the medium, which are at distance x, the path difference between those two is pi. The path difference between the two particles is x, the corresponding phase difference is pi. If 2 pi is the phase difference, lambda is the path difference. Pi is the phase difference, x is the corresponding path difference. So if I write 2 pi for lambda, pi for x, so pi into lambda is equal to 2 pi into x. So, phase difference pi is equal to 2 pi by lambda into x. The phase difference pi is equal to 2 pi by lambda into x. Here what is pi? Phase difference, x path difference. Okay. So, pi is called phase difference, x is called path difference. This is the very important relation in waves. Especially this plays very important role in superposition of waves, which we are going to discuss later chapters. Okay. Relation between phase difference and path difference. Okay. So, since 2 pi by lambda is constant, let me call that constant 2 pi by lambda as k, where k is called propagation constant or wave vector. Propagation constant. Of course, for a given wave, wavelength is constant. So, 2 pi by lambda is a constant, k is constant. So, pi is equal to 2 pi by lambda and x kx. Pi is equal to kx. So, remember that here k is 2 pi by lambda. Now, I am going to replace my wave equation y is equal to a sin omega t minus kx. Okay. Fine. So, when wave is propagating to the medium or sound is propagating to the medium, the displacement of a particle, which is the distance x from the origin, is given by this formula, okay, where a is the maximum displacement from its in position. This equation is called displacement wave equation. Y is equal to a sin omega t minus kx is called displacement wave equation.